Good day, everyone. Welcome to our presentation on neural machine translation of rare words with Subword units. Today, we delve into a cutting-edge approach that tackles the persistent challenge of translating rare and unseen words in neural machine translation systems. This research not only enhances our understanding of subword units in representing open vocabulary words, but also explores innovative segmentation strategies to optimize translation quality. Get ready to uncover how these insights shift the paradigms of language translation technology. Addressing the challenge of translating rare and unseen words in neural machine translation systems is crucial, as traditional NMT systems often struggle due to their fixed vocabulary limitations. Historically, approaches in statistical machine translation relied on back-off dictionaries or direct copying to handle unknown words, while NMT used fixed-length word vectors, creating significant bottlenecks. To overcome these limitations, we introduced a variant of byte pair encoding, or BPE, which aggressively segments words into subword units. This method not only enables open vocabulary translation, but also allows for a compact network vocabulary that can adapt to variable-length subword units. This approach simplifies the translation process and enhances the accuracy for translating rare words, providing a robust solution to one of the persistent challenges in neural machine translation. Moving on to the key contributions and insights of our research, we've made significant strides in enhancing neural machine translation. A pivotal aspect of our approach involves the use of subword units, which has proven to significantly improve the translation of rare and unseen words. This method not only simplifies the translation process, but also ensures higher accuracy compared to traditional models that rely on large vocabularies or back-off dictionaries. Furthermore, our findings challenge the conventional wisdom in neural machine translation regarding vocabulary size. We demonstrated that reducing the vocabulary size of subword models can actually enhance performance. This insight opens up new avenues for optimizing translation systems, particularly in how we handle and process language data. Let's delve into the challenge of translating rare and unseen words in neural machine translation, or NMT. Traditional NMT systems often struggle with diverse vocabularies, particularly when encountering words that do not appear frequently in the training data. This limitation becomes even more pronounced in languages with complex word formation processes, such as compounding or agglutination. To address this, we explore an innovative approach using byte pair encoding, or BPE, which you can see illustrated here. This method progressively merges the most frequent pairs of characters or character sequences, forming new subword units. This allows us to represent rare and unseen words as sequences of subword units, significantly enhancing the model's ability to handle a wide range of vocabulary with a fixed size symbol set. This figure demonstrates the BPE merge operations, showing how subword units are constructed from a sample dictionary. In addressing the challenges of neural machine translation, one significant hurdle is the translation of open vocabulary words, particularly those that are rare or have never been seen before in the training data. Traditional methods, such as back-off models or using fixed-length word vectors, often fall short in effectively handling these types of words. This limitation not only affects the accuracy of translations, but also restricts the flexibility of NMT systems. To tackle this issue, we focus on enhancing the translation of open vocabulary words. These are words that, due to their rarity or absence in training datasets, pose a unique challenge. Successfully translating these words is crucial for improving the overall flexibility and quality of NMT systems. Understanding and addressing this problem is vital. By improving how we handle these diverse linguistic phenomena, we can significantly enhance the overall quality and adaptability of NMT systems, making them more robust and capable of dealing with a wider range of translation scenarios. Let's delve into the innovative approach we've adopted in this research, utilizing byte pair encoding, or BPE, for aggressive segmentation into subword units. This method allows us to break down words into smaller, manageable pieces, effectively addressing the challenges of open vocabulary translation. By segmenting words into these subword units, we can flexibly and accurately represent words, even those that are rare or unseen in the training data. In this paper, we introduce several key innovations. Firstly, the use of variable length subword units paired with a compact network vocabulary significantly enhances translation quality. This approach moves away from reliance on large vocabularies that are typical in traditional neural machine translation systems. Furthermore, we justify our approach by comparing it to prior work, demonstrating marked improvements. Our method shows particular strength in handling languages that are morphologically rich or have large vocabularies. This is crucial because such languages often pose significant challenges for conventional translation models, which our approach effectively mitigates. Let's delve into the technical core of our approach, focusing on the byte pair encoding, or BPE, which is pivotal for our neural machine translation system. BPE is a segmentation strategy that allows us to handle open vocabulary challenges in translation by breaking down words into smaller, manageable subword units. This method is not only innovative, but also crucial for enhancing the translation of rare and unseen words. Now, how does BPE work? Initially, it identifies the most frequent pairs of bytes or characters in the text. These pairs are then merged into a single new character that previously did not exist in the text. This process is repeated iteratively, which gradually reduces the size of the vocabulary needed to encode the original text. To give you a clearer picture, let's consider an example directly from our research. Imagine the word deer. In BPE, D and E might be the most frequent pair initially and are combined to form a new subunit. This process continues until the entire word is segmented into efficient subword units that the model can effectively process. This method not only simplifies the encoding process, but also significantly enhances the capability of our translation model to generalize from known to unknown word forms, making it a robust solution for neural machine translation. In our research, we've utilized a robust training process to enhance the performance of our neural machine translation models. We trained our models using data from the WMT 2015 Shared Translation Task, specifically focusing on English to German and English to Russian, which included 4.2 million and 2.6 million sentence pairs respectively. For the training setup, we employed the Groundhog framework with the ADA-Delta optimizer, ensuring efficient convergence. We experimented with different gradient clipping thresholds to optimize training stability and performance. Notably, we found that a lower threshold generally yielded better performing individual models. During the latter stages of training, we fixed the embedding layer, which allowed the models to refine and specialize on more nuanced aspects of the translation task without altering the foundational word representations. Each model was trained for approximately 7 days, with checkpoints saved every 12 hours to capture model states and facilitate further fine-tuning. This meticulous training regimen has been pivotal in enabling our models to effectively handle the translation of rare and unseen words through subword units. Moving forward, let's delve into how our approach enhances neural machine translation systems beyond traditional methods that rely on fixed-length word vectors. Our research introduces variable-length subword units, which significantly improve the model's adaptability to diverse vocabularies and complex morphologies. This flexibility allows the model to effectively handle a broader range of words, including rare and unseen terms, without the constraints imposed by fixed-length representations. Moreover, this method substantially reduces the necessity for large neural machine translation vocabularies or fallback strategies like back-off models. By employing subword units, we can maintain a compact and efficient vocabulary that scales better and streamlines the translation process. This not only optimizes performance, but also simplifies the underlying architecture of our translation system. In our research, we delve into several empirical questions to enhance neural machine translation. Firstly, we explore whether representing rare and unseen words through subword units can improve translation accuracy. Additionally, we investigate which segmentation strategy, whether it be byte pair encoding or simple character bigram segmentation, provides the best balance in terms of vocabulary size, text size, and overall translation quality. Our experimental setup involves a rigorous comparison between different segmentation methods. We utilize a dataset from the WMT 2015 Shared Translation Task, focusing on English to German and English to Russian translations. The training involves millions of sentence pairs, and we employ both traditional and novel evaluation metrics like BLEU and CHRF3 to assess performance. This setup allows us to directly measure the impact of subword segmentation on the translation of rare and complex words. Moving on to our results and observations, we found significant performance gains over baseline models by employing both BPE and simple character bigram segmentation. This approach not only simplifies the translation process, but also enhances it by effectively managing rare and unseen words. Importantly, our experiments demonstrate that reducing the vocabulary size of subword models can indeed improve performance. These findings are pivotal, as they challenge traditional NMT systems that rely on large vocabularies and back-off models, suggesting a shift towards more efficient and scalable solutions in open vocabulary translation. Looking ahead, there are exciting avenues for future research. Determining the optimal vocabulary size for different language pairs remains an open question. This could lead to more tailored and effective translation systems. Additionally, there's potential to develop more advanced bilingually informed segmentation algorithms. Such innovations could further refine the alignment of subword units across languages, enhancing the overall translation quality. These directions not only promise to advance the field of neural machine translation, but also open up possibilities for more nuanced and context-aware language models. Let's delve into the technical results of our study, where we observed significant performance gains. By employing both byte pair encoding and simple character bigram segmentation, our models demonstrated a notable improvement over the baseline models. This enhancement is quantified by higher BLEU and CHRF3 scores, which are critical metrics in evaluating translation quality. Furthermore, our findings highlight the impact of vocabulary size on translation performance. By reducing the vocabulary size in subword models, we not only streamlined the model's complexity, but also achieved better translation accuracy. This suggests that smaller, more focused vocabularies in subword models are beneficial, enhancing the overall efficiency and effectiveness of the translation process. These results underscore the potential of subword segmentation to optimize neural machine translation systems, particularly in handling rare and unseen words. Let's delve into the technical results of our study, focusing on the ablation study we conducted on segmentation methods. We compared the performance of byte pair encoding, or BPE, segmentation with a simpler character bigram segmentation approach. Our findings clearly show that BPE segmentation excels in handling rare and unseen words, providing a robust method for enhancing translation quality in neural machine translation systems. Furthermore, the implications of these results are significant. By utilizing subword units, we've seen a substantial improvement in the translation of out-of-vocabulary and rare-in-vocabulary words. Additionally, the variable length nature of these subword units has proven to enhance the attention mechanism within our models. This leads to translations that are not only more focused, but also more accurate, capturing the nuances of the source text more effectively. This advancement is crucial for developing more efficient and effective translation systems in the field of neural machine translation. Turning our attention to the empirical results, let's examine a visual representation of our findings. Displayed here is a figure showing the English to German unigram F1 scores from the News Test 2015, plotted by training set frequency rank for different neural machine translation systems. This graph strikingly illustrates the significant impact that subword segmentation has on translation quality, particularly for rare and unseen words. To recap the key contributions of our research, we have successfully demonstrated that neural machine translation systems are fully capable of handling open vocabulary translations by employing subword units. We've introduced an innovative variant of byte pair encoding for word segmentation, which not only allows for a compact representation of open vocabularies, but also adapts to variable length subword units. Furthermore, our results show clear performance improvements over baseline models, utilizing both BPE and simple character bigram segmentation strategies. These advancements underscore the potential of subword segmentation to enhance translation accuracy and efficiency in neural machine translation systems. As we conclude our discussion, let's highlight the key takeaways from our research. First and foremost, the use of subword units has proven to be a game changer in the translation of rare and unseen words. This approach not only simplifies the translation process, but also eliminates the need for extensive vocabularies or reliance on back-off models. Interestingly, we've also discovered that reducing the vocabulary size of subword models can enhance the performance of neural machine translation systems. This finding challenges the traditional belief that larger vocabularies are always better in translation tasks. Looking ahead, there are promising avenues for future research. One critical area is optimizing the vocabulary size based on specific language pairs and the volume of training data available. Additionally, there's potential in developing bilingually informed segmentation algorithms. These could improve the alignment of subword units, making translations even more accurate and contextually appropriate. These insights not only advance our understanding of neural machine translation, but also open up new possibilities for more effective and efficient translation systems in the future.